Hello my dear students. In the previous class we have discussed about the theory part of linear programming problem. Today we will learn about the problems on linear programming problem. A manufacturer produces two models M1 and M2 of a product. Each unit of model M1 requires 4 hours grinding and 2 hours polishing. Each unit of model M2 requires 2 hours grinding and 5 hours polishing. The manufacturer has two grinders, each of which works for 40 hours a week. There are three polishers, each of which works for 60 hours per week. Profit of model M1 is 300 rupees per unit and profit of model M2 is 400 rupees per unit. The manufacturer has to allocate his production capacity so as to maximize his profit. Formulate the given LPP. Okay, here there are two models M1 and M2. Okay, and each unit of model M1 requires 4 hours grinding and 2 hours polishing. Each unit of model M2 requires 2 hours grinding and 5 hours polishing. Fine. Now here let X denote number of units of model M1 to be produced. How many units of model M1 to be produced are not known. So let us consider it as X. Let X number of units of model M1 to be produced. Let Y number of units of model M2 to be produced. Then from the given data we have here present it in a tabular form, model M1, model M2 and requirement. Here on step side, number of units, profit, grinding time and polishing time. Here I have made use of profit because in the question see here the manufacturer has to allocate his production capacity so as to maximize his profit. That's what here I have written profit. Okay, and the number of units to be produced, the number of units of model M1 to be produced are taken as X. We have taken it as X, so let us write it as X. And the number of units of model M2 to be produced I have taken it as Y, then Y. And in the last column requirement, then profit for model M1. Here you can see that profit of model M1 is 300 rupees per unit and profit of model M2 is 400 rupees per unit. So per unit it is 300 rupees and the number of units of model M1 I have taken as X. So per unit, for 1 unit, if the profit is 300, then for X units profit is 300X. In the same way, for n unit of model M2 is 400 rupees. If the profit is 400 rupees for 1 unit of model M2, then for Y units of model M2, profit becomes 400Y. And in the theoretical part, I told you that if the profit comes, if the term profit comes in the question, write down maximize. If the cost comes in the question, then write down minimize, because everyone wants to maximize their profit and minimize their cost. So in the final column, in the last column, if the term profit is there, write down maximize. If the term cost is there in the question, then write down minimize. Then come for grinding time and polishing time. Grinding time for model M2. We can observe here each unit of model M1 requires 4 hours grinding and 2 hours polishing. So each unit of model M1 requires 4 hours grinding time and 2 hours polishing time. 1 unit of model M1 requires 4 hours grinding and 2 hours polishing. So here the number of units produced for model M1 is X. So grinding time for model M1 is 4X and polishing time for model M1 is 2X. In the same way for model M2, each unit of model M2 requires 2 hours grinding and 4 hours polishing. So for model M2, grinding time is 2 hours, so 2Y, and polishing time for model M2 is 5Y. It requires 5 hours per unit for model M2. Then here requirement. You can observe here The manufacturer has two grinders. The number of grinders are 2, each of which works for 40 hours. One grinder works for 40 hours, then in total 2 grinders works for 80 hours. For one grinder it is 40 hours. For 2 grinders it is 80 hours. 2 into 40 is 80, maximum 80. Then there are 3 polishers, each of which works for 60 hours. Number of polishers are 3 and each polisher works for 60 hours. Then 3 into 60 is 180. So here I have written 2 grinders, each of which works for 40 hours. 2 into 40 is 80. 3 polishers, each of which works for 60 hours. 3 into 60 is 180 hours. So the total requirement of grinding time and polishing time. Here because of this profit, I have written maximize. So maximum means what? Less than or equal to sign. For example, if the term is like maximum 80 indicates what? It is equals to 80 or less than 80 but not more than 80. So maximum stands for less than or equals to, and again maximum less than or equals to 180. Maximum 180 stands for it is less than or equals to, it may be equals to 180 or it may be less than 180 but not more than 180. So maximum 180, it means not more than 180. It is up to 180. Okay. Then with the help of these parameters, then you have to frame the equations. So the given LPP is maximize Z equals to 300x plus 400y. So here you can look at the table. Maximize Z, because of the term profit, maximize where Z is the objective function. So maximize Z equals to 300x plus 400y. Then subject to the conditions, subject to the constraints. ST stands for subject to the constraints. 4x plus 2y less than or equals to 80. 2x plus 5y less than or equals to 180. Here I have written the LPP is maximize Z equals to 300x plus 400y, subject to the constraints 4x plus 2y less than or equals to 80, 2x plus 5y less than or equals to 180, and x greater than or equals to 0 and y greater than or equals to 0. It is compulsory to write the last condition. This is known as non-negativity restriction or non-negativity condition. So each variable x and y should be greater than or equals to 0. Okay, so this is how to form an LPP, how to form the equations with the help of given information. Okay, then in the next method, with the help of these equations you can plot the graphs. Okay, this is simply a formulation of LPP. With the help of these equations we can represent these equations by graphical method. Okay, that graphical method we will study in the next class. First we will learn how to frame the equations with the help of given information. Okay, thank you.